Hi everybody. Let's walk through this problem. So here I have lots of variations on nested looping. I've got one where there's no nesting. I've got one where the indices start at 0 in both cases. I've got one where they start at 0 in both cases, but we're trying to check that A and B are not the same. Here I've got one where B starts at the same index that A is at. And I've got one where B starts one after A. And we're supposed to try and match these different scenarios to actual examples where we might want to use them. So let's think this through. Let's say I have an array list of letters, and I want to display every possible two-letter password drawn from letters in the array. So what it's describing is this kind of situation. I've got an array of letters. Okay, well, what are all the possible two-letter passwords? I'm going to have AA, and AB, and AC, all the way down to AZ, and then I'll start over with BA, and then BB, and then BC, and so on. So it's sort of like if I want all the two-letter passwords, the first letter could be anything, and the second letter could be anything. Okay, so which of these patterns would give me that if I'm looping over the array? It seems like because I have two things that need to change independently of each other, I'm going to need some nested loops. This first one isn't going to work because I'm just looping over each thing one at a time. This last one also wouldn't really make sense because this is if I'm using A to be the location of the first letter and B to be the location and B to be the location of the second letter. This is saying that no matter what A is, B is only going to visit elements to the right of A. So if I did that traversal, I would get the password AB right at the very beginning, but I'd miss AA just immediately. So that one doesn't work either. I think because there's no restriction on what the two letters can be. They can really be anything, and it's okay for them to be the same. The pattern we want is C. Nope, B. Because we want the first letter, we want the first letter to be anything starting from index 0 up to the end of the list. And for each first letter, we also want that same set of options for the second letter. Okay, what about this one? Let's say I have an array list of student objects that have information from their classes. I want to check whether two students have the same teacher for third block. So let's think about which students we would want to check with which other students. If I wanted to check this as a human being, I would want to say, Alice, do you have the same third block teacher as Bob? Oh, Alice, do you have the same third block teacher as Carlo? What about Alice and Dravida? What about Alice and Alpine? What about Bob and Carlo? What about Bob and Dravida? So I want to check all possible pairs of students. So to me, the best answer would be E, because that's checking all the students for A, and then once I have a student, the other students that it checks with are only students that are to the right of the first student in the array. And that's definitely going to get all pairs exactly once. C could also be an answer, but it's a little bit less preferred, and here's why. For C, I would be doing this. I'd say, okay, A and B are both 0, so I'm checking Alice with Alice. But then here I'll say, oh, let's only do the checking if A doesn't equal B. And right now, A and B are both 0. So it wouldn't actually check Alice against Alice. Then we'd increment B by 1, and so now we'd have Alice and Bob, and that's okay. And then it would go through the entire rest of the list with Alice. Now let's say that we're back up at A equals 1, so we're checking Bob. We'll have B load to 0, and so now we're checking Bob and Alice. There's nothing wrong with checking Bob and Alice, but the problem is we've already done that once. We checked it when A was 0 and B was 1. And then later on, we're going to check it when A is 1 and B is 0. So we're going to check every pair twice. So I think E is the best answer. C works, but it has a lot of repeated computations. And depending on your application, that might be very slow. Okay, what if I have an array list of test scores and I want to find the highest test score in the list? Well, this is a situation where I don't need to check all possible pairs. What I really need to do is I really need to 3, 5, 8, is I really need to go through each test score one at a time and keep track of the biggest one I've ever seen so far. So initially I'll say my biggest is 10, and then I'll say, oh, let's compare 2 to 10. Nope, it's not bigger. Let's compare 100 to 10. Oh, it is bigger. Let's compare 3 to 100. Let's compare 5 to 100. Let's compare 8 to 100. So I only need to visit every score once. I don't need to check all the scores against all the other scores. So the only pattern here that matches that would be A. Last, let's imagine we have an array list of point objects, and we want to find the pair of points that's closest together. This scenario is very, very similar to this one. In this one, I wanted to check all pairs of students. And in this one, I also want to check pairs of things. I want to check all pairs of points. The only difference is, when I was checking pairs of students, I would just say, do you guys have the same third block teacher? Do you guys have the same third block teacher? Here, if I have a pair of points, I'd want to calculate the distance between them and then check to see, is it the smallest distance I've ever seen so far? Because I want to find the 2 points that have the smallest distance. So if I initialize the smallest distance to something very large, don't do this. It should be integer.max value, or rather probably double.max value. But if I initialize smallest distance to be something very large, then right away when I check the distance between 2 points, it's going to get replaced by whatever that distance is. And then I'll check another pair, I'll look at the distance, and then I'll compare that distance to a single variable, and so on. So the idea that I'm trying to find the smallest doesn't actually affect who I want to be visiting in this case, because I still want to be visiting all possible pairs. So the answer is going to be the same as up here. Either E or C could work, but E is going to be more desirable because it's not going to double compute all of the distances. I'm not going to compare P1 and P3 twice. I'm just going to do it once if I use E.